Okay, so let's talk about false position method. So this is the second type of bracketing method. Okay, for this method also, okay, anyways, so let's talk about the idea behind false position method. So in this method, what is happening is this is your x-axis, y-axis, and this is the root. Okay, this is function of x. Let me use a different color pen here. So this is my axle, this is my xu, and this is my root. And this is fx. So what we did in bisection method is we used to find out the value of xr. Okay, so what we used to do was xl plus xu divided by 2. But now in false position method, what we are going to do is we are going to, instead of taking the value of xr as xl plus xu divided by 2, we are going to take the value of xr as xu minus f xu xl minus xu fxl. So this is how you are going to find out xr, okay, in your false position method. So how did I come to this conclusion that the value of xr and the xr is this? Okay, so what we do is we follow the similarity of triangle. What we do is we draw a line, okay, and this value is going to be my value of xr, this value, and this value we find out using similarity of triangle. So if you just follow the similarity of triangle here, so this is going to be fxu, this is going to be xu, this is going to be, this length is going to be xr minus xl, and this length is going to be, this length is going to be xu minus xr, this is going to be fxl. So if you follow similarity of triangle, this is going to be fxl. Okay, so if you solve this further, you will reach at this point. Okay, so this is the idea behind false position method. Okay, so now let us solve the same problem using false position method. So the only difference between bisection method and false position method is the way of finding out the value of xr. Okay, so again everything remains the same. Okay, so I'll just write down the algorithm. So this is going to be xl, this is going to be xu. The value of xr is going to be okay, and the decision remains the same. We are going to find out the product of xl, xr. If it's greater than 0, that is going to be your xl, and when it is less than 0, this is going to be and this you are going to continue your approximate error. So let's solve the same problem. So if you guys can recall what was the problem, let me write down fx minus 0.5 x square. Okay. So we are going to solve this problem using false position method. Okay, and the value of xl, since it is a bracketing method, you should know the value of the starting lower limit and upper limit beforehand. So it is 5, 10. Okay, so again what I'm going to do here is I'm going to draw a table. Okay, it's your freedom, you can solve it anyway. And again, you can draw the table anyhow. This is my method and my way of drawing table. You might have a different method. Okay, so let us start. So what is the starting value? Starting value is 5. This is 10. Substitute these values 5 and 10 in your fx, and you'll realize that the value that you're getting is 4.5, and this is going to be minus 20.5. Okay, now let us find out the value of xr. How you are going to find out the value of xr? You are going to use this equation. Okay, so you are going to substitute the value of xu 10, fxu, fxl, xl in this equation, and then you are going to find out. So if you do so, the value of xr comes out to be 5.9. Okay, and when you substitute the value of 5.9 in fx, the value of fxr comes out to be 1.84. Now for percentage approximate error, I don't think you will be able to find out percentage approximate error at this point, since this is first iteration. So let's move on. So if you see here, if you substitute fxl is positive. Okay, fxr is positive, so this is positive, 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 comes out to be, product comes out to be positive, that means it's greater than 0. So when this product is greater than 0, your for the next iteration, your xl will be replaced by your xr. So your xl will be replaced by your xr. This is going to be 5.9. Okay, this remains the same, just copy it down here. Again, what you have to do is you have to find out fxl. Again substitute, but I don't think you need to substitute, because for 5.9 the value of fx will be again 1.84. Okay, you can just copy it from here. It is going to be 1.84. This is going to be the same, and again substitute these values in this equation, and this comes out to be 6.2376, and the value, this value, when you substitute 6.2376 in this equation, this comes out to be 0.64. Now you can calculate percentage error, and you'll find that the percentage error, approximate error, comes out to be 5.27%. So you can see how interesting false position method is. Within the first iteration, you got the value of approximate error as 5.72. Okay, but we'll not stop here, because we want the percentage approximate error to be less than 2%. Okay, so again we'll move on. Now xl is positive, xr is again positive, so again this is going to be greater than 0. So when it is greater than 0, again for the next iteration, your xl will be replaced by your xr. So this becomes 6.2376. This will be the same. This will be 7. And this is going to be 6.0.64. Just copy it from here. This will remain the same. Okay, now substitute these values in this equation, and then again the value of xr comes out to be 6.3515, and this is 12076, and the percentage approximate error is 1.8%. Okay, so which is less than 2%, so that means we have to stop here. So you can see how just a small modification in calculating the value of XR will ended up into a totally new method, and you see how fast it converges. Okay, if you can see, I think if you go back, it took us 6 iterations to get to the approximate error of less than 2%. But when I talk about false position method, it took us just 3 iterations. Just 3 iterations to get to the value, get to the percentage approximate error of 1.8% and get to the value. Okay. So this is the advantage of your false position method over bisection method. Okay. Don't be under a misconception that false position method is the best method. Okay. Since given our time and the syllabus that we are going to cover, we are not going to cover more advanced methods. Okay, we are just going to discuss till false position method or for bracketing methods. Okay, there are other bracketing method like modified false position method, which will give you much better result. Okay, there is a situation. Okay, there is a problem like this: x raised to 10 minus 1, where you will find that the bisection method gives better result as compared to false position method. Okay, so to circumvent that, what people have done is they have modified the false position method. So you will find in different books modified false position method, but we are not going to discuss that. So this is, I think, the end of bracketing method. So I hope you guys have understood, and next we'll move on to open methods.